So here we go. So here is quiz for chapter 7. Question 1. The average amount of money that people spend at Don McDonald's. Supposed to be, they're trying to be tricky there. That's supposed to be McDonald's. Fast food place is $6.50 with a standard deviation of $1.75. Is that the average amount people spend in McDonald's? I remember. All right, so average $6.50 at McDonald's. Standard deviation $1.75. 45 customers are randomly selected. All right, here we go. So we're coming down here. Notice the bar. That's the big deal, right? That means average. So they're saying, what's the distribution of the averages? Normally distributed. So you know the deal. This is nothing new. Mean, standard. The mean is whatever it was, $6.50. I guess that's the average people spend at McDonald's, not me. And the standard deviation. Now, standard deviation, it's for the group, so we're going to divide, right? So we're going to take the 1.75. It's the deviation. Divide by the square root of 45. So whatever that comes out to be. So they're saying the average person spends $6.50 at McDonald's, but not everybody is average like me, and they're off of the middle by $1.75. So the average person spends $6.50, but people are off that middle typically by $1.75. I'm way above the middle on that by a couple of deviations. So now for 45 customers, find the probability that their average spent is less than $5. That's going to be a low probability. Do you feel that? It's good. The more I can reach your math feelings, it'll help you, because we all hit the wrong button sometimes, huh? In the middle of the exam, you're going to hit so many buttons in this class, you're going to hit the wrong buttons. And by the way, one thing, calculator intensive tests, which is like all our tests in here from now on, it's good to just run them twice, in a test, I mean. If you're in the middle of the test, just do the buttons, write it down, do them again, make sure you get the same answer twice, then you probably didn't hit a wrong button. I would run them twice during the test. Anyway, but also if you just have a sense of reality about you. If the average person spends $6.50 at McDonald's, what's the chance you're going to get 45 people and their average is going to be under 5? 45 people getting under $5. That's not very likely. That's super unlikely. If the average person spends $6.50 to get 45 people by random luck that are spending on average below $5. That's not, we're expecting a super low number here. Like 0.0 something probably, or maybe 0.1, I don't know, but I don't think so. All right, let's draw a normal curve. Come up here, draw a normal curve. What's right in the middle of the normal curve? Whatever the average is $6.50. Average person spends $6.50 at McDonald's, and they're wanting less than $5. So I'm going to come over here. $5 is here. $5, my $5 mark there. And less than is to the left of $5. That's not me. So to the left of $5. So less than $5. So am I going to do, normal CDF or inverse norm? Yeah, are they giving me an area or asking me? There's no area up here, is there? They're not giving me an area, they're asking me. So that's normal CDF. It's normal CDF. You know the drill. Left edge, right edge, mean, standard. So that'll be normal CDF. So what is the left edge of that chunk of shading? Yeah, it's way over here. Negative bunch of 9s. That's left forever. So that's negative 5 9s. The right edge? $5. The mean, $6.50. The standard is going to be the $1.75. But now, is this for a group or an individual? Now, this question's for 45 customers. So I'm going to divide by the square root of 45. I'm betting this is coming out small. Because you get this confuses people a lot of times, so let me help. Here's the answer I got. I got, on my calculator, it came out 4.47847 E minus 9. I don't know if anybody did this exact one I'm doing, but it came out E minus 9. What does that mean, remember?
You move the decimal.
9 places back. That means the decimal doesn't really go there. It really needs to go 9 places back. 1 place back and you're to the edge. The other 8 places are beyond the edge. Will bring in zeros. So it's really 1, 2, 3, 4, 5, 6, 7, 8 zeros. 4, 4, 7, 8, 4, 7. What is that rounded to 4 places? Yeah. I told you the probability would be low, right? I mean, you're not going to get 45 people whose average is under $5 when the average for everybody is $6.50. That's going to be almost, it's like rolling 45 dice and having a really high average or really low average. This is not going to happen. So is everybody okay with how you do that? You could also go +1. I think, would it work on that one? Yeah. The other trick I gave you, if you're getting that during the test or homework or whatever, you can just add 1, and it'll force the calculator to show you the decimal more normal looking. You know what I mean? If you just add 1, it'll kind of make it look like that automatically for you. It's a nice trick. So this answer is 0. There's basically 0 probability. I mean, there's a super small probability, but it's basically 0. There's almost no chance you're going to get 45 people whose average is less than $5. Does that make sense? So you won't be fooled by that? And now question C says, what's the probability that 1 randomly selected customer will spend less than $5? So now we just get rid of that square root 45 thing. Do it again. Hey, you know there's a button that'll do that automatically on your calculator? Let me teach you about another button. It's called second enter. Is it? I can't see up here. It's the entry button. Yeah, second enter. See? Wait. Yeah, entry, yeah. So if you hit second enter, it'll whatever you last entered, it'll pop that on your screen again. It pulls up the last entry rather than the last answer. Right? So rather than the last answer it gave you, you're putting up again the last thing you gave it, the last entry. And I just gave it, I'm off. I did something in between. But anyway, I did the 1+, so it's not on my screen anymore. But if you had just done this one, you could hit second and entry. And it just saves you time. It's right above the enter key. And it just pops up the last thing you put in again. Then you could just erase the part at the back and get the new answer. Saves you some time because you'll be doing a lot of these. So I'm going to do it. This one will have a reasonable answer probably. Oops. I got point 1957. Did you get that? There's about a 20% chance. See how different it is? There's a 20% chance you can have one person that that's not a big deal. Say, hey, the average person spends $6.50 at McDonald's. What's the chance if you just run into one person coming out of McDonald's that he or she spent under $5? That could happen. About a 20% chance. It's not likely, but it's not impossible. As opposed to, what's the chance you're going to grab 45 people in a row coming out of McDonald's and their average is going to be under $5? That's virtually impossible. See the difference between a group question and an individual? Do you feel the difference between a group question and an individual question? So here's number 6. And which, by the way, it's just totally random in them all. So this could be your number 1 or your number 2 or anywhere. It's right now it's just grabbing whatever, 8 of them or 6 of them or 10 of them are random. So they're all, so there's basically only 2 kinds. I think it's the other kind and this kind. So when they give us that up there, they're telling us that the original variable, no bar there, notice, that's the original variable, is normally distributed. This must be the mean. Remember, the first number is always the mean. And that must be the standard deviation. So that's what they're telling us. And then they're asking us questions about x bar, the average, right? The average of groups of how big? 4. Groups of 4. Sample size 4. So then this is the mean's going to be the same. The standard deviation is going to be 10 divided by the square root of 4, which I can do that one. That comes out 5. Right? Square root of 4 is 2. 10 divided by 2 is 5. Now they're saying, what's the probability that x bar is less than 30? So let's draw ourselves a normal curve yet again. Let's put the middle on there. The middle is 30. And they're saying, what's the probability, right? Because that's the middle, that's the average. What's the probability x bar is less? That direction means less than. We good there? It's saying x bar less than 30. So where am I going to shade? Left of 30. So they want me to find what portion of the curve that is, huh? Do you know it already without hitting the buttons? That's 50%, right? You can do the buttons on the calculator if you want to, but it's going to come out 50%. That's exactly half the curve, isn't it? We're going to have to work harder on part C, but that was nice for part B, right? Because that's exactly half the curve. See what they did different there? They went right from the middle. Instead of normally like this one, they went off the middle a little bit down to $5, so we had to use the calculator. But if they're right in the middle, that's just half. How about part C? Find the 95th percentile. Remember percentile? How do we do percentile? Put the middle on here again, 30. So remember what percentile means? So percentile is a ranking from 0 to 100, huh? 0%, 100%. So if you're ranking, your height, your weight, your shoe size, whatever. Let's say your shoe size is at the 95 percentile. Then that means you're almost as far along as they come, right? If that's your blood pressure level, or that wouldn't be good to have high blood pressure, or whatever. So whatever that is, right? So that's ranked really high, really high. So that means if you're at the 95%, if you have a newborn baby boy and his height is at the 95 percentile, that means he's longer than 95% of other babies, newborn babies, baby boys, right? So anyway, so the point is that would mean you're way over here, and the 95% is the part to the left. Does that make sense? We're saying 95% of the curve, 95% of all people are lower height or whatever. In this case, I don't even know what we're measuring. So are we going to do, normal CDF or inverse norm? Yeah, they're giving me the area this time, right? When they give you the area, that's inverse norm. So this one's going to be inverse norm. Area to the left. This one does have area to the left. Is 0.95. Mean is 30. Standard deviation, are we talking about a group or individual? X bar is a group. So we got to take the original standard, which was 10, and divide by the square root of 4, because that's my sample size. Hit the buttons on your calculator. That good. And then part D. So we good for percentile? Percentile is percent below. It's always percent below, right? If you're at the 95 percentile in height, 95% are below you in height to the left. And right, inverse norm always has area left, and then mean, and then standard. Right? So the area to the left is 0.95. Finally, part D. Part D says probability that X bar is greater than 36. So let's draw that. That's a little different. So here's the middle. This is 30. So where's 36? Is that to the right or the left of 30? It's somewhere over here. And they want, which way am I going to shade to the right or the left? Yeah, because it's X bar greater, greater than 36. Greater stuff is to the right. So is that, what is it, normal CDF or inverse norm? Yeah, because they're not giving me area. They're not giving me 0.25 up here or anything, are they? They're not giving me area. They're asking me for area. So it's normal CDF, left edge, right edge, mean, standard. So normal CDF. So what's the left edge and right edge of? Left and right edge of the shading. So this is the left edge. What's the right edge? Bunch of 9s, right? So left edge is 36. Right edge is a bunch of 9s. The mean, they told me 30. Standard is 10 divided by the square root of 4, because we are talking about a group sample size of 4. This is x bar. There we go. Hit the buttons on the calculator. So we good on that one? Let me show one more. I'm going to go back to question 2. Question 2 says between 3 and 5. The other way they could write that is like this. That means between 3 and 5. So some of the problems will write it like this. That's just a fancy way to say between 3 and 5. So you would do your bell curve, put the middle, whatever the middle is. Or no. I don't know, what is the middle? Is it? Oh, yeah, that is the middle, huh? 4. So middle is 4, and then you would just go 3, 5, and then find the area between, like that.